everything is clear from your side means. So I will ask you some questions regarding the previous section, then we will go in further. Okay, so my first question is, just give me why we do the simulation jobs, why it is necessary to do simulation jobs. One of you guys please explain me why we do simulation jobs.
Sir, example to predict the oil level and to predict how much damage is in well production and related that how to do acidification job is how is done
Actually,
and
sorry to interrupt you, but your voice is not clear and there's some another noise coming from your backside. So try to speak louder and clear voice. Okay, so it will be clear for me. Yeah,
Yeah, okay, sir. I
yeah.
think the example, how many of oil level is under the reservoir, and also we done once acidification job. Then how is done in inside that, and also yeah, well, it mean yeah, production well, how the fraction is done, and also how that like related jobs, sir. How that related.
Okay, okay. Anyone of you guy can explain about why we do this simulation job?
Yes, sir, I can explain.
Yes, Prashant.
Sir, we do simulation to uh, clarify or to verify the reservoir that we have drilled a well in it. So we need to do it by various softwares and various parameters we check, and we do this because we know that we have to depend on this. The whole production will depend on this. So it will be better. It would be better so that we can manage our production.
Okay, Prashant. One question from you. That is, what is difference between simulation and stimulation? Will you please explain me the difference between simulation and stimulation?
No, sir.
You don't know about the simulation and stimulation. Okay, today means
But
yesterday the
simulation.
Dhaneshwar sir, I will show you some software side. Okay, so the
Okay, sir.
software is stimulation or simulation. First, tell me.
Simulation.
Sir.
Simulation, sir.
It's a simulation.
Okay, and what is stimulation process?
Stimulation is we are enhancing the production of the well, sir.
Okay, so yeah, Pallavi, will you please
Yes, sir.
explain me uh, why it is necessary to do stimulation job, not simulation job? Simulation job is okay. We do something in enter some data in software and start and check that it is okay for not. But why we do simulation process, stimulation process?
So stimulation, actually, I don't have that much idea about like stimulation.
Okay.
Like
Sir, can I tell?
Yes, yes, Prashant.
Sir, we do stimulation to expand the properties of the reservoir and enhance the
Expand the properties means.
properties of we do fracturing and we reduce skin and we expand our well.
Okay. Actually, accurate answer is
Sir,
if someone
can
asks
I
you
say?
about the stimulation. Yes, yes, yes. Yes, tell me.
Sir, stimulation is a process in which the well which we dig first will not be giving the required output, sir. The pressure will be become low. So we will do some insertion process, secondary process in which we insert water like that materials to get the oil, sir, to develop the pressure. And in tertiary material method, we will do some chemicals are inserted inside the well in order to get the complete recovery of oil, sir.
Yes, yes. Now this answer is 90% correct. Okay. 90% this answer is correct.
Sir,
Yes,
my name is Melvin Alex.
yes.
In stimulation, while production started, after some time, some period, some sort of contaminates like scale, wax, something will be coming into block the path. For that, for clearing that blocks, we will be going for stimulation like acid cleaning, acid stimulation, and hydraulic fracturing.
Okay.
That
So
is,
yeah, now this is
So,
100% correct. Yes. Yes, Pallavi.
so can we relate that after that simulation is a software process where we analyze the tentative ideas like where the well is dig, how much oil can come, and stimulation we can correlate like it is a physical activity to be done.
Yes, yes, yes. This is a physical activity to done to clean the damage that present inside the reservoir.
And before that means simulation has to be done earlier before stimulation. Is it so?
Yes, 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 yes.
To get a tentative
First, we
idea so
check
that
through the softwares, and when we get the proper idea and we relate this to our field, after that we get the results that our
okay.
production will start increasing. That time we start doing this job.
So it is a physical activity which we will do
Yeah.
after simulation.
Yes, yes.
Okay.
Which calling your from, Pallavi?
So I am actually did my MTech, completed
Okay.
machine design.
In which branch?
Machine design, sir.
Machine design.
Mechanical machine design.
Yeah,
Specialization
yeah,
is machine design.
yeah, yeah. Actually, in petroleum, there are some subjects related to the mechanicals also,
Yes,
like
sir.
fluid mechanics, thermodynamics. We are studying
Yeah.
more strength of material. We
Uh,
already studied this
yes, sir.
topic. Yes. So yeah, one thing is clear that what is the difference between stimulation and stimulation. Okay. Now, second question is, um, which type of acid we inject to doing the stimulation job? What, any one of you guys please explain me which what are name of
hydraulic,
the acids?
hy- hydrochloric acid.
Okay, and
Polymers.
polymers. We are not injecting polymers inside the reservoir to do this simulation job. Polymers is used to do uh, polymer flooding, means enhanced oil recovery process. Okay, Prashant.
Okay, sir.
Okay, yeah, hydrochloric
Then
acid.
HF.
Okay, one question from my side to you. What's your name? Alex, right?
Melvin
Melvin.
Alex.
Yeah, Melvin Alex. Just explain me type of formation. They're different. If you have, did you heard about carbonate formation and sandstone formation?
Yeah, 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 yeah.
Okay, just tell me, hydrochloric acid will, if we inject hydrochloric acid, so what is the formation of the reservoir? The carbonate or sandstone, and why?
If we inject hydrochloric acid, so that it will be reacting.
Yeah, it will
Uh,
reacting with the rock, and the rock formation is carbonate formation or sandstone formation, and why?
in sandstone, we can directly inject this HCl. In carbonate, we have to first we have to preflexing.
Okay.
So
Actually, your
that
answer is not up to the mark, but I will explain you. If any guy will explain me this same question, give me some answers related to this question. Any one of you guys?
So mainly HCl is used for carbonate reservoirs and HF, and there we can use mixture of HF and HCl for sandstone reservoir.
What's your name? Shubham, right?
Yes, sir.
You are petroleum engineer.
Yes, sir.
Yeah. Okay. 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 This is good answer. Yes. In higher HCl is only used in carbonate formation. Only HCl means you inject hydrochloric acid only in carbonate formation. So when your sandstone formation is there, that time you use mixture of hydrochloric and hydrofluoric acid. This point be clear for everyone?
Yes, sir.
Okay. So one question from
Yes,
Shubham.
sir.
Yes, Shubham, will you please explain me in carbonate formation what are the minerals that present in reservoir? Will you please explain that minerals name or give some
So
minerals name?
calcium, then carbonates.
What?
Mainly, so mainly calcium is present. Then calcite.
Okay.
Then carbonates are present. Oh,
Yesterday I will show you a table. In that table there are three names. One is calcite. And what are the two
Yes.
names? Anyone of guy remember these two names? What are the two names that I shown you in yesterday's? Okay, one is calcite concentration is necessary, and another one is dolomite, and the third one is shale. Okay, the three types of minerals that mainly present in this carbonate formation. And one more petroleum engineer is there. I don't remember the name of that person. Who is the petroleum engineer except Shubham?
Melvin Alex.
Okay, and there 61 students attend 60 students attend this meeting, and I remember only 2 3 guys name because he gave me more answers. What about the or 40 50 students? He doesn't respond me. So this is not good. If you want to get some knowledge, you can talk to me, you can give answers, or you can ask me any question related to this. That time your knowledge will improve. When you put up more questions, you get more knowledge. Okay. And Shubham, will you please explain me about the some sandstone reservoir formation? What is this sandstone reservoir, and what are the minerals present in this? Or some petroleum engineers, not Shubham, maybe Alex or more will give this answer.
So mainly the sandstone pores includes the bentonite, thelonite, calcite, dolomite, quartz.
Mhm. Okay, okay, these are some names and more. Alex, more names. Feldspar is there, Shubham. Feldspar is there. Okay, monocalite is there. So different minerals have different properties. So when these are some minerals that present in you give some names and some are left. So when we study on that, there's some more minerals that present in reservoirs. Okay, so now, so you get difference between dolomite and sorry, carbonate and sandstone. There is a calcite concentration and dolomite concentration are there, and there is a lot of mineral that present in the sandstone. Now, did you hear about wormholes? What is this wormholes? ये होते क्या wormholes? किसको idea है? What is this wormholes? What is the main purpose of wormholes? Why it is necessary to create wormholes inside the reservoir? In which formation it will created? Anyone of you guy hear this wormholes? What is this wormholes? Alex? Prashant? Say no. If you don't know, just give say no, sir. I don't know. So I will explain you everything.
No, sir.
Okay.
Hello, sir.
So wormholes will create. Yes, Vignesh.
Wormholes are created during matrix simulation or acid fracturing of carbonate formations.
Not acid fracturing, only in metric acidizing. Yeah, wormholes will create in metric acidizing process. Yeah, this point be okay. And which formation it will create, Vignesh?
Carbonate formation.
Good, good, good. Yeah,
Hello, sir.
wormholes will create
And
only in carbonate formation. Yeah. And just continue. Okay. So guys, wormholes will create in carbonate formation, not in sandstone formations. Okay. If someone ask you one question related difference between sandstone and carbonate formation, you told directly that wormholes will create in carbonate formation, not in sandstone formation. This point be clear for everyone. Wormholes look like means कैसे दिखते हैं? Wormholes look like a roots of tree like. So the wormholes look like a roots of tree. Same thing happen in reservoir. When we inject acid inside the formation, the wormholes will create in carbonate formation. Wormholes is nothing. It is just we can in simply way we can say this is a penetration. Means acid can remove that damage when wormholes will create. If a wormhole is created to 4 feet, it means your damage is totally keen into 4 feet. This point be clear for everyone. What is this wormholes? Because it is very important topic to do this simulation job, to learn about the simulation processes. This is very important topic, wormholes. This point be clear for everyone.
Sir, I'm not clear,
Yes,
sir.
sir.
Please
Yes, sir.
explain, sir. Sir, please explain.
Surya and Prashant is not clear. Okay. Uh, Suppose we inject, there is a carbonate formation in your, if I told you that there is a carbonate formation, you inject acid inside the reservoir. So you try to inject acid inside the reservoir, the acid will react with the minerals of that reservoir, the carbonate reservoir. It will create a channels of roots, the channels of roots called wormholes. Now it clear, Surya and Prashant? The channels of roots called wormholes.
Yes, sir.
Yeah. And in simply way, we can say this is a penetration length, or say penetration means the wormhole challenge will create in some distance, and the distance we can calculate. The results show in the graph, and the graph says that this is a penetration graph. In in 2D model, we not show the making of roots like कि कैसे roots develop होती है. We are not showing that, but in 2D model, we just say the wormholes will create in that depth. So it may be clear in my mind that our damage will start to clean to 4 depth. This point be clear? In 4th feet, the point damage will be. Okay. In group, you got the book. There is a Galamber book name is Galamber.
Yes, sir. Yes, sir.
Okay. Pallavi, in chapter number 3, have you read this chapter number 3?
So I haven't gone through the book because I got before as earlier and I was unable to go through the book, sir.
Okay,
But
no
surely
problem.
I'll go through.
Today I will explain that 3rd chapter, and in 3rd chapter, the first part is this wormhole. What is this wormhole? Why is it necessary to create wormholes in carbonate formation? And in sandstone formation, there is no wormholes will be created because the mineral composition is totally different. Here there is a calcite concentration, so wormholes will create in calcite or in carbonate formation. But when we talking about the sandstone, the totally different formation is there. Minerals are totally different, so the wormholes is not creating in this sandstone. And the penetration means when we calculate about the penetration means how our acid will go far inside the reservoir. In carbonate formation, there is approximately 10 feet or 12 feet distance it will travel, but in sandstone it will maximum 1 feet. It not travel more than 1 feet. This point be clear for everyone. This is because the mineral composition is totally different in both formations. Say yes or no. This point be clear
Yes, sir.
for everyone. Yeah.
Yes, sir.
Yeah.
Yes, sir.
That's good. When you say yes or no, that point that is very easy to understand me. Some points are clear for you or not. If some points are not clear, that time I will give brief ideas about that. Okay, so it will be clear for you. Now come to the third point. Now penetration is clear in both carbonate and sandstone formation. What is wormholes? This point be clear. Now we are talking about the pressure change. Yesterday I show you graph about the pressure change. What happen when we inject acid in formation? Okay, suppose um, we inject some acid inside a reservoir through bullheading process, means through the top. Okay, when acid go to the reservoir, it will react to the formation. Suppose the formation is approximately 100 feet. That time that acid will react to the top formation, means the first feet of that formation. It will react. When and after that the second, the third, then go to the last one. Okay, same thing will happen inside the reservoir. So when it will react to the formation, it will start to acid. Hydrochloric acid is very high reactive acid. When it react with the rock, it start to create that wormhole channels. When your wormhole channels will start to creating, automatically the damage that was present inside the reservoir was clean up. Okay, when the reservoir damage will was clean up, your permeability will start to increasing, because it will create a path to flow of reservoir fluid. So the wormhole channels is nothing, it is a path to flow that fluid. So when acid will react to the formation, it will create a roots type channel or path where it was very easy to flow fluid from your reservoir to the top of the earth surface. This point be clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, excuse me, sir. Excuse me,
So
sir.
yes, what's your name?
I am Sri Yogeshwar. Sri Yogeshwar, sir.
Yes, Sri Yogeshwar. Yes.
Sir, we are saying hot holes are in calcite rocks, sir. Calcium deposits. So, what is the term for that sand rock, that penetration? What is the term called? Is there any term for that?
We just no. We can directly say the penetration. There is no other term
Okay, sir. Thank you.
in sandstone,
Okay,
because one is wormholes, another one is penetration. Okay.
okay, sir. Thank you, sir.
Now talking about the pressure change, how pressure will change. Okay. Suppose when we start our well drilling, when drilling is completed, the production will start at first time. Okay. The permeability of that reservoir is 50 millidarcy. The production is approximately 2000 barrels per day. After few months, what will happen? There is some damage create inside the reservoir. The permeability start to reduce. Now the permeability is 10 millidarcy. We lost 40 md millidarcy permeability due to that damage. Okay, the damage
Okay,
is
sir.
creating inside the reservoir is approximately 3 feet damage. The damage radius is 3 feet. So that time your damage will create, your permeability will reduce, your pressure that bottom inside the reservoir will also reduce. Okay, the reservoir pressure will reduce, and your top pressure means surface pressure will increase. So the production will start decreasing and decreasing. Now the production is 200 barrels. The the first production when we start drilling is 2000 barrels, and the permeability is 50 millidarcy. And now the production is 200 barrels and permeability is 10 millidarcy, and the damage is 3 feet. Okay, so when we inject acid inside the reservoir, the acid will start to clean the damage. When your penetration say, or you can say the wormholes, when your wormholes will uh, create inside a reservoir is greater than 3 feet, your damage is 3 feet, and your wormhole channel will create 3 feet or more than 3 feet, it means that your totally damage will was clean at that area. This point be clear. जिस एरिया में हमारा डैमेज 3 फीट था वो क्लीन कर दिया, वहां का पेनिट्रेशन 3 फीट से ज्यादा हुआ, तो वहां डैमेज क्लीन हो गया. दिस पॉइंट बी क्लियर.
Yes, sir.
Yes, sir.
Pallavi?
Yes, sir.
Will you please re-explain this part to everyone? What I am explaining
So
you?
actually, I am a bit
What?
confused in this. I was about to ask you, will you
Okay.
please once again take a repeat for this?
Okay. Just I will explain you. Okay.
Yes, sir,
So
please, because
you
I'm
have
not a bit clear.
you have a copy and paper now. You have a copy and paper now. Just write
Yes, sir,
something.
I have it.
Sir,
Yeah.
Yeah. And first time. So yes. Yes,
hello,
Harsh.
sir. Sir, these
Yes, Harsh.
wormholes are only done during production of heavy oil, no, sir?
Wormholes. Wormhole channels will create when we do this metric acidizing job. Okay.
Yes, but the quality of oil is higher viscosity and it is heavy, no? For that, we are using wormholes to
It will
extract
depend.
oil.
If it will depend. It will depend. Suppose you want to drill in Andaman and Nicobar, there is a oil present there. The viscosity of that oil is very high.
Yes, sir.
Okay, that time you inject steam to reduce that
Yes, sir.
viscosity and to get your fluid. In different areas, there are different viscosities of oil. Okay.
Okay, sir.
Okay. So in first time, the oil we produce, the company oil produce 2,000 barrels per day. There is no damage in reservoir. There is a permeability 50 millidarcy. After 12 months or say 14 months, what will happen? The damage starts and the production will reduce. After 12 months, the production only 200 barrels and the permeability reduced 50 to 10. Now permeability is 10. Okay,
Nadu
and
pena.
the damage that comes in that layer is 3 feet. Okay. So when we inject the acid inside the reservoir, the acid will react that damage. First, the acid will react this damaged part, start cleaning that damage. When our acid will create the wormholes, when your wormholes will greater than your damage radius. Here damage radius is 3 feet and your wormhole channels will create 4 feet. It means at that formation or that layer, damage is cleaning. So your permeability automatically go to the 50 and your skin is, you can say skin or damage. Don't confuse about skin and damage. Skin and damage is same. Sometimes I use skin and sometimes I use damage. So the damage radius totally clean because our wormhole channel create 4 feet and the damage is only 3 feet. So the production automatically start increasing because it will go to that mark where we can say totally damage is clean. Now this point be clear, Pallavi, and most of you guys.
Yes, sir. Yes.
Yes, sir.
Because in matrix acidizing job, our main purpose is that to clean that damage. This is our main purpose. Anyhow, we have cleaned this damage, but to see the pressure also means your pressure will not exceed too much to create that fracture. That time your matrix acidizing job fail. Maybe you can clean all the damage. It's not necessary, but your fracture, if your fracture is created, your pressure go to the pressure, totally job fail, money lost. Okay. So this is to clean this damage. Same thing we have to done. We inject the acid. Same thing company had done. They inject acid. They clean that damage. There's some wormhole channels will create, and after that the production will start, and they can calculate the production. Uh, Due to this, we can check we get higher production or not. Okay,
Yes.
this is the stimulation process. Okay, now we are talking about fluid flow.
Excuse me, sir.
Suppose
Excuse me.
we flow of yes, Pallav.
So is then that's like repairing damage must be a repetitive process, sir. Every time when the oil is taken out, and then again the damage has to be cleared. Every time this has to be done.
Yes, same. This is repeating processes. Okay, suppose I will give you example of yesterday. I will give you example of Kane India Limited. Okay, what happens in Kane India in Mangalam field? What will happen? Yeah. Yes. Sorry, guys. Actually, in that Mangalam field, what will happen? They inject, for example, they inject. So, what will happen in that reservoir? Uh, Through injection well, they inject polymer. Hello. Yeah, guys. Yeah. So in Mangalam field, what will happen? We in company will inject. They do polymer flooding. Company inject 200 ppm, 2000 ppm of polymer inside the well. Okay, and he get only 200 ppm. So 1800 ppm of polymer inside the reservoir. Okay, after he when he see that same thing will happen, in his mind he try to do this simulation job. When this stimulation job is done, they inject hydrochloric acid. And what will happen when they inject hydrochloric acid? Uh, this If their damage is approximately 3 feet, the more damage will start to creating automatically due to this hydrochloric acid will inject. Because when hydrochloric react with the polymer, they will create more damage and the wax will form inside the tubing. So they give us our company to this problem and we start to solve this. And what will we do? We have just try to test something, and then time we get some other results. What we get, that due to the hydrochloric acid injection, this type of wax will create. Okay, so to remove this wax and to remove the damage, we inject chelating agents. The work of chelating agents is similar to the hydrochloric acid. They start creating wormholes, channels, but in different processes. They work 3 times in similar processes. What they create wormholes, remove the damage, remove that wax, and remove that polymers. In same time, they do all 4 things. So now the Kane India Limited do this same process for doing simulation. Pallavi, you asked a question that after a few days we start to do same simulation process.
Yes, sir.
So yes, because after few days the damage will created and we will start doing this simulation job. But before doing simulation job, we test that rock. We test that rock present inside the reservoir, which type of rock is there. Maybe in second time we are not inject hydrochloric acid directly. Maybe first we inject KCl in pre-flush or NH4Cl or diesel. Okay.
Yes, sir.
After that we inject hydrochloric acid. It will depend on the
Well,
composition of rock. The rock that present inside the reservoir, now the composition will change or not. Okay.
yes, sir. Yes, sir. Thank you, sir.
So um, now come to the fluid flow equation, means how fluid will flow and how we can calculate that fluid will flow only in upper direction, not in the lower depth. If your well is approximately 500 feet, your fluid you inject, if you inject 200 barrels, uh, only in 200 feet your acid will consume, the remaining 300 feet will was left. So how to calculate this, how to get these results? So there are a lot of mechanical students are there, they are not about the Bernoulli's equation. Have you an idea of Bernoulli's equation or fluid flow equation? Have you studied this part?
Yes, sir.
I think in
Yes,
second
sir.
semester, in second year, you studied this Bernoulli's equations and fluid flow equations, tangent flow, pseudo steady state flow. Have you
Yes, sir. Fluid
read this
mechanics.
topic? Yeah, in fluid mechanics. Yes. Pallavi, you also read this topic, no?
Yes, sir. Bernoulli's
In
equation.
fluid
Yes,
mechanics,
sir.
and one of Bernoulli's and fluid mechanics is there. You studied these topics many and many times.
Yes, sir.
And some petrol engineers also studied this thing. Harsh, you read this topic? Alex?
Yes, sir.
Yes, sir.
Yes. So, yeah. So there, Aditya, will you please explain me different types of fluid flow? Like one is laminar flow. So different type. What is the name of different types of fluid flow? Aditya.
Sir, a
Laminar
turbulent
flow,
flow.
turbulent flow.
Yes. Okay.
Stingy flow.
Okay.
Laminar transition turbulent.
Sir, Newtonian flow, non-Newtonian.
Laminar turns.
Sir,
Steady
like
and unsteady
partially
flow.
Then what is
developed flow and
pseudo
fully
steady
developed.
state flow? Ajay, did you hear this pseudo steady state flow? Yeah, steady state flow.
Yes, sir. Yes, sir.
Uniform and non-uniform.
Okay.
Uniform and non-uniform.
Uniform and uniform. Yes. Yeah. So different flows. So at different flows, so what happen? We can calculate this fluid flow, means Q pump rate distribution, like Q distribution we can say, or we can say fluid distribution we can calculate in each fit. Okay. So at different depth there is a different permeability, maybe or not, maybe similar. It depends on the reservoir, but we can calculate this, and I will show you a book. In this book, uh, the equation is there. We use this equation to calculate this fluid flow, means to calculate this Q distribution. Q distribution, it is very necessary for us to calculate this Q distribution. Okay. Now I will share my screen to show the equation. Now my screen is visible for everyone.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, your voice is not audible.
Sir, your mic is muted.
Sir, your mic is muted. Can't hear you.
Oh, sorry. I don't know why my mic is mute many times. Now my voice is clear for everyone.
Yes, sir. Yes, sir.
Yes, sir.
It's clear.
Yeah, yeah. First, transient flow. If there is a transient flow, so first we have to calculate this flowing bottom hole pressure. The equation of to calculate this flowing bottom hole pressure is Pi minus 162.5 is a Q. Q is what? When we are talking about production, the Q is the oil production rate. When we talking about the injection, the Q is injection rate. This point be clear what is production and what is injection. Injection means when you inject some acid inside the reservoir, and when we talking about the production, the Q is the oil production rate. Okay, so the equation is this. So using this equation, we can easily calculate flowing bottom hole pressure when we have a value of production rate. If some company is not providing you a bottom hole pressure, if they provide you the production data, due to that production data, you can easily calculate your flowing bottom hole pressure. If some company at the time of injection, we use this equation Q. Here in this Q, we can calculate this using this equation. Here is K is what? K is permeability. Permeability into height minus Pi. Pi is initial reservoir pressure minus flowing bottom hole pressure divided by 162.5, 2.6. Bu naught and mu naught. P naught is what? Oil viscosity and oil formation volume factor. Okay. Here mu naught is given. This is a viscosity of oil, and this B naught is oil formation volume factor, that also given in, I think, in below. So T is nothing, T is time. Suppose if you
Sir, your mic is muted.
Sir, your mic is muted, sir.
okay, just I don't know what happened. I don't mute them out, but automatically. So what we can share. Oh. Now this is visible now.
Yes, sir.
Yes, sir.
Yes, sir.
So this T is time. Okay. Here T is time, and mu naught is viscosity of oil. B naught is oil formation volume factor, and K is permeability. Remind this words when someone give you the K, it means permeability, and some you give the value of P small pi is initial reservoir pressure, PWF flowing bottom oil pressure. Okay.
Yes, sir.
And here S is skin factor. So using this equation, you can easily calculate Q. Means, so for example, you inject 10 BPM barrels per minute fluid inside the reservoir. Means hydrochloric acid you inject to 10 BPM. The totally 10 pump rate will distribute in all layers, okay, in all 100 feet, you can say. We can, and the sum of distribution of q is equal to the 10. The basic purpose of this is, for example, um, I have 10 rupees and I want to distribute to 10 people. I give 1 to every 10 people. The sum of the 10 is equal to the total money that I give, that I have. So same thing happen in this q distribution. When you start to inject through 10 bpm, the total distribution of q in each layer, the sum of this q is equal to the 10. This point be clear for everyone?
Yes, sir.
Using this equation, if your permeability is too high, it means your fluid will go in maximum in upper, means high permeable zone. If your fluid viscosity is permeability is low, your fluid flow in upper section is very low. So totally depend on the permeability. If the zone is high permeability, more fluid will consume in that part. If the permeability is low, low fluid will consume in that part. Okay. Now come to the steady state flow equation. This is steady state flow equation. This is very simple equation. The equation is KH PE minus PW. P is in here, PI is given, here P is given, but both are same. Okay. This is the initial reservoir pressure. So PI minus PE minus PWF divided by 141.2. B naught mu naught is oil formation volume factor and oil viscosity. Ln of RE by RW. R is drainage radius and RW is valve radius, and S is skin, means the damage skin is. That time you can easily calculate the Q distribution using this equation. Now come to the pseudo steady state flow equation. The pseudo steady state flow equation is different. Using this equation, you can easily calculate this Q distribution. Guys, these equations are only used when your well is vertical. This equation is not used when your well is horizontal or slanted. These equations, these Q distribution 3 equations, only used when your well is vertical. This point be clear now? The equation is clear. When you read this book, that time,
Yes, sir.
more things will be clear. If you have any doubt, you can ask me now about these equations or about the something. Guys, any questions?
Sir,
Yes.
while acid then we'll use inhibitor, no, sir, to prevent the corrosion. What type of inhibitor will use
To prevent that?
for acid corrosion, sir?
Hello? Yes. Your voice is very low. Will you please speak louder?
Sir,
Yes.
sir, in acid
You're talking about
fracturing, we
inhibitors,
use
no?
inhibitor, no, sir. Hello?
We are not talking about acid fracturing. Here we are studying about the metric acidizing. When you study about the acid fraction, it's totally different.
Okay, sir.
Okay. Now you are
Okay.
talking about the inhibitors, no?
Yes, sir.
What is this inhibitor process? What is this inhibitor?
So no, sir. While we are doing acid fracturing, corrosion may occur, no, sir. Inside the well.
The corrosion inhibitor, you can say that. Okay.
Okay. Sir.
When we inject acid, we mix some inhibitors in the acid, or at a time of pre-flush we mix some inhibitors like corrosion inhibitor, like some surfactants, like some mutual solvent, like like emulsions. So it will depend on the composition, that rock composition inside the reservoir. Different reservoirs have different rock compositions. Okay, so you cannot say that every reservoir you can use different inhibitor. No, it will depend on the composition of rock. Okay, at the time of pre-flush, we mix this inhibitor and we inject this inhibitor inside the reservoir to prevent our this casing or the tubing. Okay.
Okay, sir, but
Any questions related
will
to these equations, guys?
Excuse me, sir.
Guys, any question related to this topic? Yes, yes,
So,
yes.
so,
Pallavi?
so we started like with fluid flow equation. These are these equation, those
Yes.
equations. So you said that if
Yeah.
500 feet is that, and only 200 as acid will be consumed, right? Hello.
Yeah.
So remaining 300. So
Yes, yes, yes.
remain 300 remain as it is. So by using this calculations and all, what is I'm
Yes.
like what I understood is like remaining the 300 where we are supposed to make our acid to go. So we are using these equations for the same reason. Is it
Using,
so?
hmm Using this equation, you can
Huh?
find out which formation is treated and which is left. Using this equation, you can easily understand where your fluid is flowing. For in example, I will explain you about 200 feet. Using this equation, you get this 200 feet result. The remaining is you get 0, 0, 0. It means there is no fluid flow distribution in that layer.
Okay. Huh.
That time, this equation is used to calculate this part. Okay.
Okay.
The use of this equation is this. When your well is vertical. Okay. Not talking about the horizontal well.
It's for vertical well.
In horizontal well, yeah. In horizontal well, there are a lot of papers are there to calculate this Q distribution. The most good paper and most research paper from I have experienced is Joshi equation. In Joshi equation, this is your Joshi's equation. Here KH is what? KH is horizontal permeability. In reservoir data, yesterday I have show you the KH by KV. Okay. Guys?
Yes, sir.
Sorry.
Yes, sir.
Yes,
Oh,
that
yes, sir.
KH means horizontal permeability. Guys, one thing I will told you, no one can tell this part to any petroleum engineers. Due to logging process, the permeability that comes in graph, this is horizontal permeability. It was very difficult to calculate vertical permeability. We get only ratios of KH by KV. This point be clear? Only horizontal permeabilities we can easily calculate through logging process. But it was very difficult to know about your vertical permeabilities. Because when we inject a logging tool, the waves traveling inside the reservoir is horizontally, not in vertically. So this point be clear now. So the permeability that comes in graph is your horizontal permeability.
Yes, sir.
Now before using this Q equation, we calculate this A. A here A we can say that A is used in this equation. So A, to calculate this A, we use L by 2. What is L? L is length of horizontal section. I will show you the length of horizontal section. What is this length of horizontal section? How to calculate or how to get this length of horizontal section? I will show you. Yesterday I will show you the image now of horizontal well. Here,
Yes, sir.
I will explain you what is the length of horizontal section.
Sir, what is that A?
A is nothing, is a term which is used to calculate Q. But in using this A, there is a term of L. Now my screen is visible now.
Yes, sir.
Yes.
If someone told you about the length of horizontal section, the length of horizontal section is in this horizontal. Now, you see my arrow here.
Yes, sir.
This from this to this point. This is your length of horizontal section. This is your L. Okay. If someone told about your length of horizontal section, this is your length of horizontal section. Okay. Here, the reservoir. This is a reservoir. This is a reservoir. Okay, and your well is drilled between the reservoir, and this is your length of horizontal section. If someone talking about height of the reservoir, so from this point to this point, this is your height of reservoir. This is your h. This point be clear now?
Sir, please
Guys,
tell
any
again.
questions related to length of horizontal section on height?
Sir, please tell again the length.
Please explain one more time.
Your drilling completed to this point, okay, but the tubing is in this point. Here there is a packer. After the packer, there is a open hole completion. This is open hole completion. Okay. So in this open hole completion, from the packer will start to this point to this end point. This is total is length. This is your length of horizontal section. Means you are horizontally, the length of that pipe is horizontally. That time this length is called length of horizontal section. And suppose your height of reservoir from your reservoir is from here to here, and the total height of reservoir is this. You can easily, he give you the height of reservoir. Okay, using this parameters height of reservoir. And now I'm told about to tell you about how to, why it is very easy to calculate uh, the horizontal permeability, not vertical permeability. So guys, this is your vertical part and this is your horizontal part. Okay, this is your horizontal section and straight is your vertical section. When we inject a logging, suppose this is a logging part, this is a logging tool, and the sensors that present here, like this is a sensors. Okay, these are the sensors. My image is clear now. This
Yes, sir.
image is clear now. The blue one that I have, the rays, the wave
Yes.
that comes in this logging part like this. The ray traveler like this. Okay, the horizontally ray will traveling. Okay, horizontally section. That time the permeability that comes in graph, this is horizontal permeability. It was very difficult to calculate this vertical permeability. They provide you the KH by KV ratio. Using this KH by KV, you can easily calculate your vertical permeability. When KH by KV is 1, it means your horizontal permeability and your vertical permeability is same. This point be clear now? Guys,
Yes, sir.
Sir, then why is
this point be
it?
clear
Yes,
now?
sir.
Sir, sir, I have a question.
Yes.
Sir, you said it is very difficult to calculate the vertical permeability, and this is the formula KH by KB is equal to 1. Then how is it difficult?
Mm-hmm. No. I don't tell you the formula. I give you the example. KH by KV equals to 1. Sometimes KH by KV is 100. Sometimes KH by KV is 10. Sometimes it's 2.5. Sometimes it's 7.5. It will depend on the rock formation. When we take the sample of rock,
Okay.
that time at the lab, we can calculate this KH by KV ratio.
Okay, sir.
Now come to the equation. Using this, we get the value of A. Now we can calculate IANAI. Hello? My screen is visible now, guys.
Yes, sir.
Yes, sir.
Yeah. And this is pseudo steady state flow. Sorry, the relation of this Q is from Joshi equation. See, here is mentioned in Joshi paper 1998 present the following relationship considering steady state flow of oil in horizontal plane and pseudo steady state flow in vertical plane. So I explain you about the Joshi equation. This is the Joshi equation. So in this equation, what is this KH, guys?
Horizontal permeability.
Horizontal permeability.
What is this KH?
Permeability of
Right.
horizontal.
And what is height H? What is this
Height of
PE?
reservoir.
Initial reservoir pressure. What is PWF?
Flowing water mole pressure.
Right. What is beta in here? Beta or mu? You can say
Oil
mu naught, mu naught,
formation
or you can say
fraction.
B or mu.
Volume
Oil
fraction.
What is all
formation.
formation volume factor? B is all formation volume factor and mu is all viscosity. And what is L? Length of horizontal section. What is RW, guys?
Radius of well bore.
What is RE? RE.
Radius of a reservoir.
Drainage radius.
Drainage radius. Okay. Drainage radius. Now come to the production equation. Penetration equations are not present in this paper. I will give you how to calculate this penetration part. There is an equation. You can easily calculate your productivity index, not production. When we're talking about the production, we can multiply the pressure difference of reservoir pressure and bottom hole pressure. Suppose your reservoir pressure is 3500 psi and surface pressure is 200. The difference between is 1500 psi. The value when we get the pi, we can multiply by this. That time we get this production value. So this is productivity index J. If there is a liquid phase, means if you have single phase, if your only oil is present inside a well, only in vertical well, if your fluid radial transient flow, if your fluid flow is radial transient flow, we use this equation KH by K 141.2 mu naught B naught ln of RE by RW plus S. If there is a steady state flow on vertical well, we use this equation. If there is pseudo steady state flow in vertical well, we use this equation. Okay. If only steady state flow, the example of this equation is this. Here we calculate. So this is a formula. Using this formula's parameters, you can easily calculate this productivity index. Actually, your session is only for 3 days. So I will also how to calculate in this equations in Excel. You can easily make your model in Excel. You are not do codings and do something like that. You use these equations in Excel also. Easily calculate all these parameters. So now come to the what is wormhole channels will create. Now I will show the image of wormhole channels to everyone. When you read this book, now this is very means most of the students will read this book to basic understanding about the production, everything. Okay, guys, this book is very good for you. Now come to the chapter number 16. This is metric acidizing chapter.
Sir, can steam opt perform acid fracturing?
SteamOpti only
Hello.
a software. Yes, yes. SteamOpti is only a software to do metric acidizing jobs, not fracturing jobs. If you want to see the fracturing jobs or fracturing software, we have Frac Advance, where we do hydraulic fracturing and acid fracturing. Okay.
Frac Advance.
Yeah, Frac Advance.
Okay.
Yeah. This is a metric
So that
acidizing.
Frac Advance is also made by Petrosoft.
Petroleum soft. Yes.
Okay. So the
Now come to the penetration
Petrosoft
part.
has
Yes,
main.
yes, yes.
Sir, in what else
When
domain do
companies
Petrosoft provide
petroleum
their
soft.
software? So means first in yesterday lecture they told us that it is for your screening, and second one was that SteamOpt and Frac Advance. So these are the main software which Petrosoft is working on. No?
Yeah,
Okay.
these are the main softwares. Now this is your dissolving power of acid. Means when acid react with the your carbonate formation in metric acidizing, what will happen? So here there is different mineral composition. Okay, molecular weight of acid is there. Using using this formula beta. Beta is nothing. This is dissolving power. Means how much your rock will dissolve when it react with the acid. Okay. So first we calculate this dissolving power. Like here 15% of HCl when we use, they dissolve 0.2 lbm of calcium carbonates. Okay. After that we can calculate dissolving power ratio, means volumetric dissolving power using X. Okay, now I will give you the show the image. Yeah, here is the image. Guys, this is your wormhole channels will create. This type of wormhole channel will create in carbonate formation. This image is visible now.
Yes, sir.
16.2. This type of wormhole channel will create when we inject the acid. And this is your rock sample. This is your rock sample. Any questions guys related to this? So now talking about your sandstone. We are talking about in previous we are talking about the carbonate. Now come to the sandstone. I have told you that different minerals have different compositions. If there is a high permeable zone greater than high permeability, means if your 100 md greater than, means if your reservoir has greater than 100 permeability, that time you use, if quartz is 80% and clay is less than 5%, the mixture of 10% of HCl and 3% of hydrofluoric acid. Means this table will show the different minerals having different their own using mixture of hydrochloric and hydrofluoric acid in sandstone. This point be clear now, guys? Hello.
Yes, sir.
Yes, sir.
Hello.
Yes, sir.
Everything is clear, na guys? If you have any doubt, you can ask me. If you are not asking me any question, then I am asking you some questions. If you are not giving the answers, it's not good. So you first you ask questions, then I will ask you. Now, what we have to do, we calculate this means Vm is nothing. Vm is just key how much your acid will consume to calculate this part, and we calculate this beta means your initial dissolving power. After calculate this dissolving power, we calculate the pressure, and the pressure calculation we can calculate hydrostatic pressure. Petroleum engineers, will you please give me the equation of calculate hydrostatic pressure? What is the basic equation we use this hydrostatic pressure?
0.05 into rho into H.
H is
Hello.
what? The total height of reservoir, the height from top to bottom. What
Height,
is this height?
total height,
Total height.
TVD.
Okay. TVD. True. When you're talking about height, don't say height. You say TVD. TVD is different. Height is different. TV is true vertical depth. The name of TVD is true vertical depth.
And for
That time you use the TVD. Okay.
and for
Yeah.
and for volume
So
calculation,
we
use
calculate
MD,
this
major depth.
major depth, right? So to calculate the bottom hole pressure after doing acidizing job, we can say we can calculate flowing bottom hole pressure minus hydrostatic pressure plus friction pressure. To calculate this flowing bottom hole pressure, there is if different equation. So first calculate this friction pressure. This is the equation using density of fluid, using injection rate, using fluid viscosity. The fluid viscosity is injected fluid viscosity, not the fluid present in the reservoir. Tubing diameter, tubing length. So using these parameters, you can easily calculate your friction pressure. Here is an example.
And so in
Where
yesterday,
can easily calculate.
sir, I have a doubt.
Yes.
Hello. Yes, sir. In yesterday
Yes.
session for the stream optic, you have shown a graph in which there was
Yes.
fracture pressure and bottom of flowing pressure, and below that there was a stimulation injection pressure. So, what was the use of that stimulation injection pressure?
Yeah. This is a stimulation injection pressure is that when your acid will react with the formation, okay, that time there is some pressure will start to decline. Okay, you can say stimulation pressure, you can say zone at that zone the pressure will start to decline at the time of acidizing. That zone pressure is there. You can calculate, you can say when we react this, when this is a name that give by the company, stimulation pressure. Okay, this is nothing. When acid will react the formation, this is called stimulation, and the pressure that will decrease due to this reaction is called stimulation pressure. Okay.
So, is there any relation between stimulation injection pressure and flowing bottom hole pressure? As it was very low, sir. It
Is
was
there
in the range
any?
of 470, and our bottom hole flowing pressure was somewhat around 4,000. Is there any relation between stimulation injection pressure and flowing bottom hole pressure?
No. It is totally different. It is totally different.
So, okay.
It is totally different.
So we use stimulation injection pressure just to
Flowing
determine
bottom
the
hole
zonal
pressure is
pressure
different.
differences.
Simulation process.
Yeah. I was asking that, sir.
Yesterday when I see your graph, our bottom hole pressure is 4,500, right?
Yes, sir. And our stimulation injection pressure was somewhat
This is
around
your bottom hole
470.
pressure.
Yes, sir.
Yeah.
Okay, sir. Understood.
So in when you see this example case, we can easily calculate using this equation your maximum pump rate. Means suppose there is a well, and if you inject 20 barrels per minute, high pump rate injection, due to this the pressure will exceed to the fracture pressure, damage your metric acid doesn't job fail. So that time first you have to check which pressure is maximum to to inject. Means if you calculating this something is 10 ppm, if you go to the below of 10 ppm or 10 ppm, not exceed the 10 ppm. Okay, so using this equation, this example is there. Same thing, you can easily calculate your surface injection pressure. This equation is used to calculate the surface injection pressure. Okay. Now we calculate the volume per feet calculation. Means in each feet, how much volume is consumed. Using this, we can easily use this formula, volume per feet. VH equals to pi d square QH square RWI by NAC. NAC is acid capillary number. Okay, guys. You can also using Reynolds number equations. Okay, and this is your Deckard model. Yeah, guys. One more topic is Deckard model and Busse-Glassbergen model. Okay, in Deckard model, we only use volume means wormhole propagation model. You can say this is a Deckard model. Means where wormhole channel will create. We do testing in lab. In testing in lab, we get this PVBT values, pore volume breakthrough values, and VIOPT's values. And using these values, we easily calculate the penetration, or you can easily calculate how much volume will go inside the reservoir or how in long depth. Okay. But when we're talking about the Busse-Glassbergen model, it is totally different. In some companies, they have lot of money will use to do testing in lab, so they left this part. They do that simulation job directly. So that time our model will use the Busse-Glassbergen model. In that we are not using the core flood analysis data. Only we use the some data that we are requiring. Only using that data, we easily calculate the penetration part. Okay, this is your metric acidizing part is clear. This is your metric acidizing, how it will done, and I will give you just, this is only a briefly explanation. If you want to go deep and deep and deep, it will take long time. Means take 1 year or 2 years. Okay, because we also take 3 years to develop this software. Okay, and most of companies will take more and more years. So this is only just briefly explanation. If you want to learn more and more, you go deep and deep in this metric acidizing. Now, any questions, guys, related to this metric acidizing part? Any questions?
Sir, uh, sir, how do post flux of acid, such as a KCl, helps in our stimulation process? As it only just pushes the
Post flush.
main fluid into the more into the formation, or what is more use of post flux of KCl?
KCl brine. You are talking about KCl, no?
Yes, sir. What is used of post flux?
Yeah.
First we have done pre-flux, then we are moving for main fluid, and after that we are moving for post flux.
First, I will tell you what is the use of pre-flush, what is the use of KCl brine in pre-flush. Okay, if there is a clay type damage inside the well, suppose clay is present inside the reservoir, so due to this we are not doing directly simulation job. First we have to remove this clay type solution. Okay, to do this we are injecting KCl brine. KCl brine and an H4Cl will help in this clay like damage, to treat this click like damage. Okay, at the time of pre-flush, when we're talking about the post-flush, in post-flush same thing will happen. It push the acid inside the reservoir and also prevent our formation for the clay deposition. Okay, Vijay, it prevents for the clay deposition.
Okay, sir. For
at
if
the time of post flush.
sir, if in the case if in the reservoir there is clay percentage less than 1%, sir, then what is the use of pre-flux? Is it only acting for the clay, or there is
less than 1%?
Yes, sir.
No, it is acting only for clay. If the clay is present, we inject KCl brine 1. Or if there is a formation water incompatibility, if the damage is formation water incompatibility, that time you inject this KCl brine 1 or NH4Cl. If your damage is oil water incompatibility, that time you inject xylene and toluene. Nowadays, xylene and toluene are banned because this is a cancer agent. So we inject chelating agents at the time of free flush also, like GLDTA or HETTA. Any question, guys?
And sir, in STEM Opti, I couldn't remember. Is there any option for different formation types such as sandstone or carbonate? In yesterday's session, I couldn't able to see.
Different
Is there in STEM Opti? Is there an option for different type of formations? So
different type of formations.
yes, sir. For carbonate,
Yes,
yeah.
yes.
Okay,
When
I
you
was
select
couldn't able
when you
to see that.
select sandstone module,
Okay.
I will show you the carbonate formation, carbonate model.
Okay.
When we log in the sandstone formation, there is a lot big table. The monolite is present there, dolomite is there, feldspar is there, quartz is there, monosilicate is there. So different shale is there. So lot of minerals are there, and different minerals are different compositions. So this is a long table. Okay, guys. Okay, Vijay.
Okay, sir.
Okay. Any question, guys? Prashant, Pallavi, Shubham, Harsh.
No, sir.
So
No, sir.
No. Means you clear now what is this stimulation process and why it is necessary to do simulation job before doing stimulation. This point
Yes,
is
sir.
clear now.
Yes, sir. Overview is clear, but we need to study that book for deeper understanding.
Yeah, that book for third paper, chapter number 3 you read, chapter number 16 you read. If you want to uh, learn about the hydraulic fracturing, there is chapter number 17 also there. So
Yes, sir.
don't mess up with hydraulic fracturing, means don't mess up with fracturing and simulation. Okay, simulation is different and fracturing is totally different.
Sir,
Or more, guys, approximately here. Yeah, Vijay.
sir, I want to use that STEM Opti if I can solve any case study. As I solved using FracPro and different software, I was not familiar with STEM Opti or that fracture advance. Can you arrange, sir, 1 day or 2 day trial session for me so that I can access the software?
You want to do case studies in SteamOpti.
Yes, sir. STEM Opti or Frac advance.
Like advanced.
If it is
For
possible, sir.
this, we're talking about the Rameshwar sir.
Yes, sir. If you can talk.
Maybe or may not be. Actually, I don't know.
Yes.
First, I will talk to Rameshwar sir.
Yes.
If it's possible, that time only in meeting, I will give you the access, and you show to everyone how how your inputs will enter, how you're doing this job, and that time everyone know about this. They understand how they are doing this software and stream optic will
Okay,
work.
sir.
Okay,
And
Vijay.
yes, sir. Okay.
And which college you are from, Vijay?
Sir, I'm MIT Pune. I'm from MIT Pune.
Okay, you are from MIT Pune. Okay,
Yes, sir.
okay,
Subham
okay.
Mane is also
Good.
with me.
Actually, in past, okay. Actually, in previous section, there's lot of guys from MIT Pune. There's chemical engineers. Aishwarya is there.
Yes, sir.
There are a lot of guys in MIT Pune. Yeah.
Yes, sir. It will help for my if
Pallavi,
for adding any project. So please talk to.
if you want to ask any question related to the stream opti, Aishwarya and uh, one more name is there. There are 3-4 people from MIT Pune in same batch. They will help you. Okay, Vijay. Yes, Pallavi.
no, so you called me like you said Pallavi is. Hello.
Okay. Now everything is clear for you now. Means you have any question regarding simulation or stimulation or any doubt you can ask me.
Yes, sir. I have a question. Hello,
Yes, Prashant.
sir. Is there any other software?
Abhinav, will you please mute your mic, please? Abhinav. No, yes, Prashant.
Sir, is there any other software for simulation other than SteamOpti?
Yeah, there are a lot of companies will develop this stimulation software. Uh, if you're talking about Salam Bajar, Halliburton, you're talking about Baker Hughes, you're talking about different companies. There are a lot of companies who develop different softwares. So SteamOpti developed by Petroleum Soft.
Okay, sir. Sir, we are
One
using.
is SteamCade. One
Okay.
is you want to use this software, so you have to pay approximately a lot of money to use this type of software because the fees of this software is very costly. Only oil and companies will pay this
Sir, I have another question.
amount. Okay, Prashant?
Sir, we
Yes,
are
Prashant.
working on this software. So we are doing simulation or stimulation. Hello.
What? Yes, yes,
Sir,
yes.
if we are working,
So your voice is break.
sir, if we are working on these softwares, so my question is, we are doing simulation or stimulation?
Pallavi, will
Sir,
Pallavi?
Yes, sir.
Yeah, one of you guys please give the answer of this question.
So
Prashant asked some
simulation.
question to you.
So simulation.
Okay.
So we are working on any kind of a software to calculate certain values. That is a simulation.
Okay.
Right. And when we're talking about the physical
Physical
properties that we have done
uh,
directly in field, this is a stimulation process.
stimulation. Yeah.
Yeah,
Okay,
Uh,
sir.
so
good.
I want to ask you
Yeah,
something.
good, good.
How though we work on
Yeah.
simulation software, uh, do you validate that values with some thing of simulation software? What you get the
Yes,
values?
yes,
Do you
yes, yes.
validate it?
Yeah, yeah. Actually, yes, yes, yes. We validate
Uh,
all the values. Actually, for example, when you are a company, if you build up a oil and gas company, you want to purchase a software for my company. If I sold you, that time when you enter some values, for suppose a guy who does not in oil field or is not a petroleum engineer, he's a mechanical engineer. When he see there is a valve radius and he enter value 90, so 90 feet or 90 inch, there is no valve radius is 90 feet or 90 inch. Maximum 12 to 4 to 12 range. Okay, so we validate all the values also there, and we also validate the results. The results also validate with different SP papers and different field case studies. That's why our software will use maximum companies
okay.
in Gulf and in India also. And yeah, any question guys from your side?
Sir, do we need to first do simulation after that stimulation? Is this correct, sir?
Yes,
Okay, sir.
yes, this is correct. Before, because if you directly do stimulation, suppose where fluid will loss, suppose because one topic is left, one is diverter topic is left. So I will explain you diverter topic. But suppose if you inject your hydrochloric acid, like a Kane India Limited, that he doing hydrochloric acid, so this create more damage. So company will lose, lots of money will lose, and the company go to the loss time. Okay.
Okay, sir.
So before doing this, we do simulation job. Then after that, we do simulation part. Okay.
And sir, how the
To
data is,
save money,
sir, how the data is collected for simulation?
what?
How data is collected
How data is collected for the
simulation?
simulation?
Yes, sir.
How data is collected?
Yes, sir.
Okay. Yeah, simulation. They say log data that comes from a software. There is a LAS file. Okay, there is a software to collect all the data of reservoir. Using that software, we collect oil and gas companies collect the data in Word file or in PDF file. That data we give it to us. We can inject LAS file directly in our software. Automatically, our all inputs are filled. They read all the data and automatically all inputs are filled. And we just click on run simulation. Automatically, run simulation will done.
Okay, sir.
Also, also when we do coil tubing in horizontal section, there is another software to calculate in which depth your coil will go. Suppose your well is approximately 20,000 feet horizontally, and you think that your coil is go to the last depth. This not happen. Okay, so only in 1500 feet it will only bend. So same thing you can easily calculate by this a software to calculate in which depth your coil is go. So at according to that depth we start doing simulation job using coil tubing.
Okay, sir. Sir, but
So every for new, yeah.
sir, you have shown a picture of a horizontal well, and you have shown a part in which
Yeah.
a drill having the sensors. So, what are the functions of that sensor? So I think that they must be collecting the data.
Yes, sensors after drilling is completed. After drilling is completed, we inject a logging data tool. Okay,
Okay.
that collect the data of that reservoir. Or
So that tool collects the
uh,
data.
before doing this before doing this perforation, we inject the logging tool inside the reservoir. They collect the data. Okay.
Okay,
Okay,
sir.
guys, can you explain me what is different between open hole and cased hole? Petroleum engineers will give the answer of this question because he know very well about uh,
In open
cementing, casing.
in open hole, we will be not using cementing or casing. We just keep on drilling. For cased hole means we will be cementing and casing for that.
Okay. And what is this perforation part?
It will come under the close completion, sir.
In
After
which in open hole or in cased hole?
case process, sir.
Which we use this
Cased
perforation
hole.
part
Cased hole.
in cased hole. Right. How perforation is done, guys?
With the help of perforating gun, sir, which is lowered with using wireline tool or tubing.
Okay. And how many shots coming from a single time in perforation guns per feet? There is some value in per feet, na? So how many shots will done in per feet? Alex, any idea or Shubham?
It depends upon the angle, sir.
Maybe depending upon the
Suppose your
face
well is
holes.
vertical. Actually, there is the value is approximately 8 to 12 per feet. The tube, the perforated gun in per feet, there are 8 to 12 slots. They shots to 8 to 12 in per feet. Okay.
So it may be also 4 also. So it's totally depend upon the short phasing pattern, sir. Means angular phasing,
Yes, it will depend
is
on the
it
shelf size.
0
Yeah,
degree, 45 degree, 60 degree?
yeah, yeah.
Depending upon that, these shots are performed.
In this session, there's a lot of peoples are there, but I hear only 10 to 12 people's voice. What about the remaining one? Abhinav, Abhishek, there are a lot of peoples are there. They cannot. Danish is there. Why are not giving the answers and why not asking the questions, please?
Sir, please
Hello,
explain
sir.
it.
Rishibalan here.
Yeah, Rishi. Yes, yes.
Sir, actually, we are new to this topic, but and I need to go through the book what you have sent in that group. I didn't have any time to go through the book since I'm currently working in a company. So after going through the book and relating to the topics that you have covered today, so I'll get into the fact and after if I get any doubts, I will get it clarified in the tomorrow's session, sir. Is it okay?
Okay, guys. Okay, okay, okay. No problem.
Okay, sir. Thank you.
Now come to the diverters. Okay, guys. Yes, Prashant.
Sir, please
Yes,
explain
Guru.
the question again. Open hole and close case hole.
What?
Sir, please.
Open hole and case hole?
Yes, sir. That you have that question you have asked.
Uh,
Please explain this again.
okay. Um, can I explain you in Hindi because when we explain in English, I think it's very difficult to understand you because I give you just simple example.
Okay, sir.
Is it possible, Prashant?
Yes, sir.
Okay. घर में नल का देखा है? घर में ड्रिलिंग होते हुए देखा क्या बोरिंग होते हुए देखा तुमने?
Yes, sir.
जब घर में पानी का बोरिंग होता है, तुम
देखा।
तो दिल्ली से बिलोंग करते हो, वहां पे नहीं होगा मगर तुम्हारे, हाँ, तो तुमने देखा होगा जब तुमने बोरिंग करवाया उसके बाद उसमें प्लास्टिक का पाइप डालते हैं
Yes, sir.
बोरिंग होने के बाद।
Yes, sir.
तो जो बोरिंग, आप सपोज करो तुमने बोरिंग कराया 200 फीट तक, अब तुमने पूरे 200 के 200 फीट में पाइप डाल दिया प्लास्टिक का
ठीक है।
जिसमें कोई होल नहीं है।
ओके।
ठीक है, उसे कह दिया तुमने केसिंग है, वो केसिंग वाला पार्ट है।
ओके।
ठीक है, वो केसिंग है।
ओके।
अगर तुमने नीचे उसके अंदर जाली लगा के एक होल हुआ हुआ पाइप डालते हैं, उसके बाद हम प्लास्टिक वाले जो वो पाइप होते हैं जो चारों तरफ से कवर होते हैं वो डालते हैं। जो वो होलो वाला पाइप है वो परफोरेशन गन से उस प्लास्टिक वाले पाइप में शॉर्ट्स लग गए। क्लियर है प्रशांत?
सर लास्ट का पॉइंट क्लियर नहीं हुआ।
वो जो गोल गोल होल हुए वो परफोरेशन गन ने वहां पे परफोरेट कर दिया या होल क्रिएट कर दिए जहां से आपका पानी आप पियोगे। वो पानी तभी तो आपके पास आएगा ना ऊपर, जब आपके पास वहां कुछ होल्स होंगे। प्लास्टिक पाइप से बंद कर दोगे तो कुछ आएगा ही नहीं ऊपर।
यस सर।
है ना? वो हो गया केसिंग के अंदर परफोरेशन। नाउ कम टू द ओपन होल। अब आपने पूरा क्या कहते हैं बोरिंग कर लिया, उसमें कोई पाइप 200 फीट तक बोरिंग किया, सिर्फ 100 फीट तक पाइप डाला, बाकी के 100 फीट जहां आपका पानी मिला आपको उसमें आपने कोई पाइप नहीं डाला, डायरेक्ट पानी को आने दिया। वो आपका हो गया ओपन होल कंप्लीशन।
ओके सर।
इन सिंपलेस्ट फॉर्म।
ओके।
Now clear na, because you are from belonging from mechanical department na?
Yes sir. Clear.
If I explain you about the open hole and cased hole, it take I think 2 hours because there's lot of purpose. It means first start drilling, after drilling we do cementing, then casing, then drilling, then cementing, then casing. So it will take 2 hours to explain this topic. So I'll give you a simple example for this.
Okay sir. It's clear. Thank you sir.
Shubham? Shubham?
Yes sir.
मैंने सही एग्जांपल दिया ना बिल्कुल?
हाँ सर।
मैकेनिकल्स को, क्योंकि
हाँ
उनका
सर।
फील्ड थोड़ा डिफरेंट होता है, तो
हाँ
उसका
सर।
रिलेटेड ये एग्जांपल सबसे सुटेबल होगा।
हाँ सर।
अगर कोई मुझसे पूछता है ना सकर रोड पंप के बारे में, तो मैं उनको नलके का एग्जांपल देता हूँ, हैंड पंप का, कि वो
हैंड
कैसे वर्क करता है। सेम एज एसआरपी, या
यस सर।
सेम एज एसआरपी वर्क करती है। हाँ, तो अब हमारी रियल लाइफ में ऐसे बहुत सारी चीजें जो हम अपनी फील्ड से रिलेट कर सकते हैं उस चीज को।
हाँ सर।
नाउ कम टू द डाइवर्टर टॉपिक। Diverters are four types of diverters is there. One is viscosified diverter. Another one is foam, VES, viscoelastic surfactant, and fourth one is particulate diverter. The name of the diverter is these four. Lot of companies use different names of diverter. Some companies have 20 to 100 diverters they are using, but in marketing, these four are very similar. Most of they using these four diverters because, like a company like Halliburton and Schlumberger, they make their own diverters and they cannot disclose their name. They cannot disclose their properties. So it is very confidential. So these four diverters are viscosified diverter. The name of viscosified diverter. What is the purpose of viscosified diverter? We inject a gel form fluid like high viscosified fluid inside the reservoir. When high viscosified fluid inject inside the reservoir, what will happen? They get deposit in that high permeable zone in upper zone. When our acid will react with the formation, they increase the permeability. The upper portion is high permeable zone. They will go and settle down at high permeable zone, and some in remaining one. After diverter, viscosified diverter, when we inject acid, the some acid will traveling in upper zone, but most of the fluid will go downward direction because there is some, you can say, some high gel fluid that cover that permeable part, means they resist that fluid to traveling inside. The the viscosified diverter works like that. Okay guys, any question this about viscosified diverter? Any guys have any question related to this viscosified diverter? Then we will move to the foam diverter.
So can you please explain it again?
Sir, why we use diverters?
What's your name? Sorry, what's your name?
So my name is Samidha.
Hello. Okay, Samida. You're from which college?
So I'm from Lakshminarayan Institute of Technology, Nagpur. LIT.
Nagpur, and you are doing BTech in which branch?
Chemical engineering.
Chemical engineering. Okay. So viscosified fluid, you can also say this is a gel fluid, gel form. When highly gel form fluid, when you inject this fluid, the upper zone is treated in first acidizing job. When you do after we do pre-flush, after pre-flush, when you inject acid, the acid will treat only upper zone, okay, upper 100 feet zone or 200 feet zone, and the remaining 300 feet zone is left. So the gel will settle in that 100 or 200 feet zone because the permeability is increases. When the permeability increase, easy to flow fluid, the fluid will settle in upper zone and the remaining zone is left. After that, when we inject acid, some of fluid will travel because there is some permeability now. So acid will go inside the reservoir, but most of the acid will go in lower direction. So that time your lower zone will also treated. This is your viscosified diverter work. This is gel diverter with high viscosity.
Okay.
Now come to the foam diverter. Um, Alex, will you please explain what is the purpose of foam at drilling time? Did you know we use foam used as a drilling time? Alex or Shubham?
It is,
Because I think you
sir.
both are
Hello,
from
sir.
petroleum side. Yes,
It
yes.
is used as a lubricant to reduce the friction during drilling. Hello, sir.
And also, and one
And
more,
collect the
it can easily, uh,
Leave
yeah,
the
it collect the,
settings.
sir.
yeah, left the cuttings. Yes, yeah. Now, what is the use of foam in here? The foam, same thing as diverter is done, viscosified diverter, same thing foam is done. We inject a foam fluid. When foam fluid, we are not injecting foam, we injecting foam fluid. When foam fluid will react the upper permeability zone, it create a foam inside the reservoir. When it react with the formation. Yeah, Vignesh, will you please mute your mic? Yeah. When we inject our fluid, foam fluid, when it react with the formation, the foam will create inside the reservoir. Okay, we are not inject directly foam inside the reservoir. We create foam, we inject foam fluid. The foam fluid will react the formation automatically. It prepared look like it will automatically change their property. It will create a foam, and the foam will settle in upper zone, and same thing will happen. And the best purpose of foam, matlab is the foam is good enough when we talking about viscosified diverter and foam diverter. I suggest you the foam diverter is best. The reason behind that, the viscosity it will increase more than viscosified diverter. That upper zone, they packed all that upper zone with respect to the viscosified diverter. Okay, same thing happen when we inject acid. The acid will go in downward direction because our upper part is totally packed with that foam. This point be clear, guys?
Yes, sir.
Or any questions
Yes.
regarding this?
Sir, please
Sir,
one again.
Okay. Now,
Sir, again one time, please.
yes. Again one time. Okay. We inject foam fluid inside the reservoir. Okay. The foam fluid will react with the formation. Automatically, the property will change. It create a foam in a whole that part, hollow part. It create foam type of layers. It create foam. After creating foam, when you inject the acid, they prevent that acid to inside the upper formation due to the high viscosity. The fluid will travel downward direction. This is the main purpose of this foam diverter. Now talking about VES diverter, viscoelastic surfactant. VES diverter is a fluid. This is a elastic fluid, you can say, or when it is depend on your when it react with the VS diverter is best diverter in all the diverters. Why? I will explain you the reason behind that. This is a elastic fluid. Second thing, it react with the formation. When it react with the calcite formation, they change their calcite concentrations also. Due to this, they reduce their permeability more and more. Due to this, the fluid easily go more and more fluid. Like if you inject 100 barrels, only 10 barrels will in upper zone and 90 barrels will go downward direction. So this is the viscoelastic surfactant fluid is this. This fluid will react with the calcite concentrations. Okay. they reduce their calcite concentration. This is elastic fluid. So due to this elasticity, so you can it will divert the fluid from upper zone to lower zone. So 90% of fluid will go in downward direction, only 10% in upper direction. Not talking about the particulate diverter. Same like a foam diverter, but foam will create the foam. Here we are when we're talking about the particulates, we inject benzonic acid, benzonic flakes, you can say. We inject some benzonic flakes or benzonic acid inside the reservoir. The benzonic acid will react with the formation. They can change the means the nature of that rock for few times. मतलब after 1 hour or you can say in 1 hour, it can change the nature of that rock. Due to this, that it work as a diverter. Okay, it doesn't mean that some it can create some layer. No, it can create change the nature of that rock. Particulate diverter. Different particulate diverters, different fluid are there. Benzonic acid, one of them. So when you search and read more papers regarding particulate diverter, there are a lot of papers are there. Okay, guys.
Sir, please compare this foam diverter and particulate diverter, their functions.
Foam diverters, when foam will create inside the reservoir. But when particulate diverter, we are talking about particulate diverter. This is a fluid that change the property of that rock. Means uh, it it reduce the permeability automatically. Means some benzonic flakes uh, block that pores, the pores of that permeability, block that pores. Okay, the benzonic flakes fix that pores. It automatically create damage. This damage is temporary damage. Okay, due to this temporary damage, the skin will automatically increase and permeability will reduce. Okay, Prashant?
Skin will increase.
Skin will increase, yeah,
Okay.
and permeability will reduce.
Okay, sir.
So, guys, can I ask you a question? Sorry, I have a doubt before drilling. We collect the data by just I read this. Sorry, collect the data by seismic method like what type of layers undergo and water in above all the oil layers fully pump water layer and after get oil. Yeah, there are a lot of method to collect the oil. Rameshwar sir explained about primary recovery process, secondary and then tertiary. Then one is hybrid, enhanced oil recovery process is there, and submersible method is there. So there are a lot of methods to get the oil. Okay, guys. Okay.
Hello, sir. Hello.
Yes, Surya. Yes, Aditya.
Sir, I'm new to this, sir. But for the last 4 days, I wasn't there, sir. I joined just today, so I don't know, how the course is designed to tell us, like teach us. Like, can I know more information about this, sir?
Which topic? Which topic you need more information, Aditya?
No, sir. Like, now you are taking the drilling and the topics, drilling topic. No, sir. The next we have refining or what? Like the structure we have.
Okay. Um. So sorry, I don't get what you're asking. Means I don't.
Sir, like how is it scheduled
Please
to, sir?
brief what
Hello.
schedule. Okay, you're talking about the schedule, na?
Yes, sir.
You're talking about schedule.
Yes.
So schedule, I think uh, it will give in your group. I think John will send it. Okay.
Okay, sir. Yes.
So guys, stimulation process is uh, done. The equation that we have to use, I will give you the equations. In I think tomorrow, my session is there, maybe or not. I don't think so. If my session is there, so tomorrow what we have to do, we do some testing. We try to do run cases in StreamOpti. Is it okay for you? We do some testing or run some cases. One is open
Yes,
hole,
sir.
one is cased hole,
Yes, sir.
horizontal well, vertical
Yes,
well,
sir.
cased hole. Is it
Sir.
okay for you,
Sir.
guys?
Yes.
Yeah.
Yes, yes, sir. Very okay.
Ah, okay. Okay. So tomorrow, what we have to do, we if my session is there, so I'm trying to run some cases and explain you each by each part and then get the results and see how to check the results. This results is okay or not. Can you check the details of the officially website, Mr. Okay, okay. Okay, guys. Now today's session is over. Thank you for everyone.
Sir.
If you have any doubt, you can ask me. Okay.
Sir.
Yes, Guru.
Sir. Sir, I am new to this topic, but can you share this recording for us?
What can you
Able to share this recording? Recording.
recording sending? Okay. I think yes. Actually, I'm not doing this recording. I think Rishi.
Hello. Yeah, Adib sir.
Yes, sir.
Yes. Yes,
Yeah.
Rishi.
Hello.
Rishi,
If
yes, sir.
anyone needs recording, please send me a message and I'll share the recordings.
Okay.
Yeah. We are doing.
Yes, sir.
Yeah. So whatever any queries or anything, just put on the message in a group so that we'll know what is done.
Okay.
Yeah. Okay.
Okay, guys.
Adib, sir, are you there?
Yes. Yes, Rishi.
Sir, did you call me?
Okay, okay. I will call you. I think you send me a message now. My WhatsApp number.
No, sir, I haven't sent you any message.
Hello. Actually, I have number of Anthony.
Yes, sir. Yeah, I've sent you a message. Hello.
Okay, okay, Rishi. You send me a message, then I will call you.
No, sir, I didn't mean that.
Okay, guys.
Okay, sir.
Okay, okay, guys. Bye. Now today's session is over.
Thank you, sir.
Thank you, sir.
Thank you so much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.